Hello and welcome to episode 4 of LogiCast, the podcast brought to you by LogiCarta, where we take a deep dive into the previous week's AWS news. I'm Carl Robinson and I'm joined by my colleague John. Hello John, how are you doing today?
Hi, I'm alright. I'm in a different shed today.
Tour of the World Sheds. LogiCast brought to you from the sheds of Great Britain. Where is your shed today, John?
Cornwall, just about.
Very nice. Very nice. Well, I'm in the same shed as usual, so no interesting shed facts from me. We've got a number of articles that we're going to talk about this week from last week's AWS news. If you haven't heard the podcast before, you may or may not know that each week I produce a curated list of AWS news in a weekly AWS News Roundup newsletter, and in the LogiCast podcast, John and I select a number of those articles that we just want to talk about in a little bit more detail. So the first of those articles this week is again from the Register. We seem to be liking the Register. I think the last episode we had 2 or 3 articles from the Register, but we've got another article from the Register today. It's actually a sponsored feature, this one, but interesting nonetheless. All about the recent launch of the Amazon Neptune serverless graph database. So Neptune itself is not new. The Neptune graph database has been around for a little while in AWS, but last week there were a lot of headlines that we spotted about the new serverless version of Neptune. So John, what can you tell me about Neptune and graph databases? I think, as always, you know a lot more about this than I do. I know virtually nothing other than what I've read from this database. So yeah, what can you tell us, John, about graph databases?
Yeah, sure. So, graph databases, they are a different type of non-relational database, right? I call them non-relational. They're a NoSQL database. They have relations, but not in the way that a relational database traditionally does. There's 2 types. I'm significantly more familiar with one than the other. The 2 types are, and it does say this in the graph, but there's property graphs and knowledge graphs. Property graphs are the ones that I'm familiar with and that most people on the planet will have actually had some data stored in, because they're used quite a lot for social media. I think Facebook is built on a property graph database, because what they do is they store data in nodes, they call them nodes, it's just like an item, and relationships between those nodes. So you have a person node per person as opposed to something like a person table, and then you have information on relationships between those sort of person nodes. So you have a John node and a Carl node, and those 2 nodes are, John works for Carl, Carl knows John, that kind of thing. So that's the short version of a graph database. As you say, Neptune has been around for a little while now, 2017, 2018 I think, but it certainly isn't the first to the market. There was another graph database provider that I'm aware of, and I'm sure there's more, but there's one called Neo4j, which is, I don't know what the J stands for, I think it was originally Java based or something like that. But so Neptune isn't kind of the only player in the market. As you say, Neptune's been around for a little while, and up until this announcement it was much more kind of RDS adjacent, if you like. It worked in the same way that RDS did. It had servers, it dealt with the control plane, but you paid EC2 rates for the servers underneath it, and you kind of worked in that sort of way. You did auto-scaling in the same way that you did RDS, you had endpoints in the same way that you had with RDS, and so on and so forth. With the serverless offering, what they've gone and done is they've made it work much more like a DynamoDB model, which sort of makes sense, right? Because that's AWS's primary serverless NoSQL database, and they've kind of modelled other serverless databases, Aurora being the other one, on top of how that works. So you pay for what you're using as opposed to the servers that you've got. And rather annoyingly, they've come up with another way of confusing people taking an exam. So, as you well know, with DynamoDB, you pay based on read and write capacity units. With Aurora, you pay, I think, Aurora capacity units. With Neptune, you now pay Neptune capacity units. So that's just another thing you're going to have to do the maths on in the exam, which is just great. The article does go on to talk about how this is also used not just for social media but for security and fraud detection and stuff, because again, unpredictable loads, which, when you need to scan something, when you need to scan it, you don't know in advance when you need to do that potentially, and you pick up fraud and things based on strange relationships between pieces of information, between data, and that's exactly what these graphs are great for. Graphs, databases, that's exactly what they're great for, because that's what they're storing. And yeah, as you say, this is a featured article, but I thought it was worth just bringing up because there was a lot of noise about this one. They are growing in popularity, hence the amount of noise, I think. So yeah, this is just another option, and potentially it's probably the cheapest way of getting going with a graph database. It's also worth knowing that AWS seems to be quite committed to Neptune as a service, because since 2017 or 18, whenever it was released, they have added a number of things to it. The most interesting being the support for open cipher query language, which, if you're familiar with something like a SQL query language, will feel quite familiar, much more so than the language it launched with, which is Gremlin, which I've never really used and never really wanted to. But Cipher looks and feels like SQL, right? So when you've got Cipher support, when you've got serverless support, all of a sudden this graph database becomes very, very approachable to people. So yeah, thought it was worth a look.
And can I just say Tinkerpop? Simply because I want to test the pop filter on my microphone. It's just one of those things, Tinkerpop. Doesn't seem to belong in an IT conversation, really, does it? But it's in this article. I just wanted to say Tinkerpop. And hopefully that's coming through loud and clear over my mic. Another bit of waffle, as is my tendency. If you listen to the last episode, you'll know that I'm the waffle. No, you're the waffle. I'm the cheese. I got it the wrong way round. Anyway, I'm going to move away from this could be a bit cheesy. Definitely a little bit of waffle. But you mentioned Neo4j there, so I'm going to go off on a complete tangent. I was walking out Southend Pier last weekend with a friend, and somebody called my name, and it was a guy called Johnny James that used to work at CloudReach, who now works for Neo4j. Told you I was going to go off on a tangent, completely random. Do you remember Johnny James from your CloudReach days?
Oh, vaguely, yeah, vaguely.
Yeah. So anyway, he was pushing a pushchair along Southend Pier, the world's longest pleasure pier at 1.3 miles. And I was waving at the child in the pushchair who waved back at me, and then the guy pushing the pushchair called my name. So yeah, there we go. Completely, not completely random, because he now works for Neo4j, but not really a great deal to do with graph databases, is it?
He could have called you something other than your name, so you got away lightly, I think.
He could have done, although I don't think we knew each other that well. I'm just glad he remembered my name, which is nice. So anyway, I think that's enough about graph databases for now. Let's move on to the next article. So this one from Renato Lozio on InfoQ is about AWS introducing AWS parameters and secrets Lambda extension to improve performances and security. So my understanding of this at a high level is a new way to retrieve secrets for Lambda functions without having to go into Secrets Manager. So you can either confirm or deny my understanding, and perhaps elaborate a bit on that, John.
Well, yeah, you're not wrong. It is a new way of retrieving parameters from SSM Parameter Store and secrets from Secrets Manager without having to go all the way out to the services. Now, as the article says, and this article towards the end also just has a lot of links out to Twitter feeds and things as well, because that just seems to be how they've done this. As the article says, traditionally, the way you pull in things from SSM Parameter Store or from Secrets Manager is you initialize bot03, this is in Python language, right, but you initialize the SDK or part of the SDK, you load up the relevant thing to say, I want this kind of bit, and then you go off and you get it and you pull it back in, and then you've got to filter out all the other bits that aren't the value that you don't want. So things like, how many API calls were needed and how long it's been stored there and when it was updated and all that jazz, where 99% of the time when you're pulling it in a Lambda, you actually only want the value. So that it was kind of faffy. And then on top of that, Secrets Manager has a charge for using the API. And whilst SSM doesn't have a charge for using the API, there are limits that you need to worry about. And if you're working in Lambda scale, you can start to hit the ceilings of those without really trying too hard. Yes, okay, you can turn on advanced concurrency and then you're paying rather than hitting ceilings, but neither is amazing. What this is doing is via the use of a Lambda layer, and I'll touch on why that's not amazing in a minute, it's loading in a cache for both Secrets Manager and SSM Parameter Store, and then allowing you to, as a developer, it's allowing you to talk to that cache via an HTTP GET request to just pull down the thing that you want. You don't have to load up the SDK, you don't have to talk out to the service, it's just kind of there. So as the article says, this is a cost and latency reduction measure, because you're not going out to the service, so you're not paying the API costs, and you're not going out to the service, you're it's a bit hard to comprehend this, but even within the data center, there you are constrained by the speed of light. Yeah, so your requests, because they're not going any further than kind of where the Lambda's running, because it's a local cache, is faster because it's not going off to where this other service is stored and then coming back again. You're talking microseconds of latency, but it's there. If you do this enough, and you do this at high enough scale, that does start to become a problem. So it does make it faster. It's, like I say, it's loaded in via a Lambda layer, and that's the only real issue I take with this. I understand why they've done that. So layers, if you're not familiar, is a way of importing external code or external dependencies into your Lambda runtime environment. Yeah, typically I've got a lot of experience of doing this with Python, and what we do is you'd put your Python pip dependencies in a layer and then load that layer in, so you're not gumming up your runtime environment, you're not gumming up your deployments and all that jazz with pip dependencies, because they can get quite messy and unruly, and you just kind of want to keep them away on their own. Putting this in a layer is kind of the obvious way to make it available to Lambdas that want it, and not have other Lambdas that don't need it have access to it. Because because at the end of the day, that's a security risk, because it's an unauthenticated GET request. But putting it as a layer does mean, because layers are limited, you can only attach 5 of them to any one Lambda, and there's a size limit as well when this is unrolled, 250 meg or something like that. So if you've got a large number of other layers already attached, you might not be able to use this because you've hit a limit, be it in count or size. So that's kind of the biggest issue I take with this. But on the whole, it is a fantastic service change, because it's a cost reduction, it's a speed improvement. The article does also have a few annoyances around the fact that it's an HTTP local server cache, which, okay, yeah, they sort of cop to say that it makes sense so it's supported across runtimes, but having a language-specific AWS-ified call would have potentially been nicer to work with, because GET requests can get messy. But yeah, on the whole, absolutely great. Absolutely love this. Want to see more of this sort of thing.
So I guess the big question is, will you be using it? We're about to embark upon a serverless project of one of our clients. Will you be using it?
Absolutely, 100%.
Cool. Thanks for that insight, John. So let's move on to the next article, which is from the AWS database blog. It's about demystifying Amazon RDS backup storage costs. One of the trickiest things about using RDS can be figuring out all of the little hidden costs. Obviously, there is a free online cost calculator that you can use, but you need to be AWS certified really to understand what all the various input parameters are, and it's asking you to often estimate things that you wouldn't have a clue about from your own environment. But we've got an article here that does attempt to demystify backup storage costs for RDS. Can you demystify it any further, John, having read the article?
So this is an area of AWS that I'm quite weirdly passionate about. I did go off on one a couple of episodes ago about this as well. So it's good that they're talking about it, because I really think they should make more of this. The article is pretty good. It's a little bit dry, but it's quite detailed. The areas that it sort of starts to talk about is, the variables, as you say, that affect cost of backup retention, and that's the size of the database, the workload patterns, how long you're keeping your backups for, how often you're initiating manual snapshots because they're not automatically kind of purged for you, and then anything else that's going on in that region in your RDS environment. In terms of each of those areas, the database storage size you get, say you have a 1 terabyte, I think they use a TB as an example on here, but potato. Say you have a 1 terabyte database, you get 1 terabyte of backups as well for free, which is great. What that functionally means is in a production environment, you get your first backup. It doesn't cost anything. Brilliant, lovely, love that. And of course, if you're running, say, dev and production in the same space, and you turn off the dev backups because you don't necessarily need them, you could, if they're equivalent sizes, have 2 production full backups for free, which is wonderful. That's nice. It's not amazing, but it's nice. And then they talk about retention period, because automated backups have retentions of between don't take them and 35 days. And obviously you pay for the number of them that you're having, right? So if you're keeping them for 7 days, you get the first one for free, and then you've got to pay for the next 6. Cool. Talks about the frequency of manual snapshots, because you pay for the storage, but they're not automatically deleted. They're not rotated out for you. So you've got to take account of that. And then it talks about, other things in the region which I've touched on, and backup policies and all that sort of thing. It then runs through some nice scenarios, and then it gets into some graphs and things. But I'm going to focus on scenario number 2 from their article and just sort of talk through that. So in this, they have a 1000 gigabyte database with 700 gig taken up and a daily change in the data of 50 gig, right? So
can I just interrupt you there, John, for a moment?
Sure.
Because can you clarify for me and anyone else listening the difference between megabytes and megabytes and gigabytes and gigabytes? Because it seems there's a trend now towards using more of the megabyte unit. And I'm not 100% certain of the difference. So what is the difference?
So traditionally, a gigabyte is 1024 megabytes. Yeah. A gigabyte is 1000 megabytes, which is 1000 kilobytes. So the IBI, as opposed to the IGA, if you like, is around 1000, and the mega, giga, peta, whatever bytes is a binary expansion in 1024.
Got it. Thought
So
that
it's
was the
just
case. Thank you for clarifying, and sorry for interrupting. Carry on with your scenario, but I just wanted to know that for my own personal benefit, really.
Fair enough. So yeah, in this, I'm just going to say gig because it's easier. They've got 1000 gig provisioned, and it's using 700 gig and changing 50 gig a day. Yeah, you get the first 1000 for nothing, which is great because you're already paying for the database storage, so you're already paying for that externally, and in your backup land, you're not paying for another 1000 for the first 1000, right? So you have the first 700 gig, that's covered in the free tier, and a daily change of 50 gig. So every day your 700 gig has 50 gigabytes worth of change. Yeah, that means you are paying 700 plus 7 times 50, which I'm not doing the maths off the top of my head. I think it's 1050. So they take away that initial 1000, and you're paying 50 gig a month. Bosh, done. You're really not actually paying very much for this because it's something like 1 cent per gigabyte per month, or gigabyte per month. So it's quite cheap. And that scenario 2 really, I think, for me, sums up how backups are kind of designed to work, how they're meant to work, and how they recommend they work. Because it's automated, it's got 7 days worth of retention, and I know there's probably recommendations for it being longer than that, but it's automated, 7 days worth of retention, it rolls out, and you're actually not paying very much there, because all you're paying for is kind of the rate of change.
Got it.
There are other scenarios in here as well, and then they've got simulations and things, which I'm not going to go into because, the article does it better than I can, because there's nice sort of CloudWatch graphs and bits and pieces. But yeah, it's well worth a read, this one, but you will want a cup of coffee.
Got it. And we will be including the links to the articles in the show notes. So if you want to actually read through the other scenarios, take a look at the pretty graphs, etc., then encourage you to take a look at the show notes, and you can link out and have a read. So on to the next one then, another AWS blog post. This time it's from the AWS Cloud Operations and Migrations blog, and the title of this post is Monitoring the Availability and Health of On-Premises Application Using AWS CloudWatch Synthetics. So obviously AWS are moving more and more into the observability space now, not just for AWS services themselves, but also for services operating outside of AWS. Some might argue they're eating some of their customers and partners' lunch with this, but that's often the way that these things tend to evolve. So certainly CloudWatch is able to do a lot more now than it was a few years ago. Yeah, what's CloudWatch Synthetics, John? What can you tell me about that? Before you do, I just one thing that I noticed about this article, and it's I think it's just my OCD. It's something that I pointed out with one of your diagrams recently. It's using some of the older generation service icons, which I'm very surprised to see that on the AWS blog itself. I would have thought they would have had an editor with eyes as eagle-eyed as mine, who would be spotting these things and editing them out. Not that it's particularly relevant, but I just wanted to point that out.
I think that's an artifact of Amazon's org structure. Lots of two pizza teams that don't talk to each other. I think that's what's done that. Right, so as you say, this is a very detailed blog on a very specific area for synthetic monitoring. I'll touch on synthetics first, and then I'll go through the article. As you say, this is a little bit lunch-eaty for some of their partners. So traditionally for synthetics monitoring, and a synthetic monitor is the site available? Can I hit this page? Do I get a 200 response? That sort of thing. Making sure that the site's up and available for your customers, but it's called synthetic because you don't have a person doing it, it's a service doing it. Traditionally, you'd go to New Relic or Datadog or one of those sorts of people for APM monitoring, and synthetics and canaries is covered in their APM, right? So yeah, this is a little bit lunch-eaty for those sorts of people, but it's still early days, and the offerings in the marketplace are quite mature compared to CloudWatch. CloudWatch Synthetics work in the same way that a normal canary synthetic would do, right? It's a configurable script that in this case I think actually runs in Lambda, which is great, because then you can just go and edit it yourself, happy days. And it hits endpoints. This particular solution is telling you how to do it with an on-premises hosted application, so that you don't have to go off to someone like Datadog specifically, who are then treating it like any other application, and just kind of spamming an endpoint. You have private connectivity from your AWS VPC back to your on-premises, so that you're not clogging up public routes, if that makes sense. It's a fairly complicated setup, but it's a relatively simple diagram. So you create the synthetics, that goes off and sort of spins up the lambdas for you. You don't have to worry about that, but if you want to customize them, you can. You have private connectivity back to your on-prem setup, and if your DNS is hosted on-prem as well, then it tells you, to use Route 53 resolver to sort of send forwards, because lambdas have to have a DNS in the VPC if they're in the VPC. And it sort of runs that and sends the results back to CloudWatch metrics and S3 buckets and that sort of thing, and then you can alert based on that. But yeah, it goes through setting up what's called a heartbeat canary, right? And a heartbeat canary is literally just calling out to a service every so often to say, are you there? Are you there? And making sure that it's still kind of up and running. It goes into massive detail on how to do that, and VPC settings, and making the canary, and then if you need the hybrid DNS for Route 53 resolver, which is actually really useful because the documentation on Route 53 resolver itself is not amazing, I don't think. So this is reasonable, and it's nice that it shows you how to do that, and then it shows you how to look at your run metrics. It's important to note that whilst this blog post talks about doing it specifically for on-prem applications, you can do it for AWS hosted applications as well, which I suppose is sort of more common, but yeah, just a nice article showing you that you can still use AWS to do these sorts of things for probably cheaper than New Relic or Datadog or other APM people are available, even if you're not hosting your application in AWS. So yeah, nice little good one there.
Cool, thanks for that. And I hope the authors don't mind me pointing out the use of the incorrect icons. Be interesting to see if they do actually get updated.
Have to tag him in the post.
So back to the register again for our final article of this week. This one is about AWS buying over 100 diesel generators for Irish data centers, which I think I mentioned in my my weekly news roundup video. Does seem a little at odds with some of the sustainability agenda that is being so heavily pushed by all the vendors at the moment. But Amazon has applied to have 105 diesel generators installed at a new data center site in Dublin. What can you tell me about this, John?
So, yeah, you're not wrong. This is a little bit at odds. Spinning up a whole bunch of dirty diesel burning generators to run your data center is somewhat at odds with, going green and renewable power and all that jazz. In this specific case, as listeners, viewers in the UK and Europe will know, we are probably going into a fairly uncomfortable winter with fuel availability, for ongoing reasons. This specific one, this article talks about the fact that Ireland is very, very data center heavy. Yeah, there's a lot of them in Ireland. AWS has a region there which has at least 3 data centers, probably more than that, because it's 3 AZ, and each AZ is at least 1 data center, but probably more. I think Google Cloud might have a region there. I know Azure does. It's very heavy on the data center in Ireland, to the extent that power consumed by data centers in Ireland uses more power than all of the rural homes in Ireland. That's just what? That's mad. You're spending more money on power to run server farms than you are keeping people that don't live in cities connected to the grid. That's wow. But okay, cool. That's sort of the crux of this article. Because of the sheer amount of power these data centers are using, one of the things that their regulator in Ireland has required is they are giving priority to applications where, and I'm reading verbatim here, where the data center has the ability to reduce its electricity demand, typically by using its own generators or storage capacities. So that's what this is. It's a licensing thing from Amazon's perspective, I would suspect. They're more likely to be able to get the licenses for more data centers if, when required, they can reduce their grid power requirements. So in this case, it's by spinning up a bunch of diesel generators. Happy days, they don't need Irish power, they've got their own. The other obvious options being things like Tesla's giga batteries or whatever they're called. Other battery suppliers are available, but big storage batteries where you pull in power and charge them overnight when it's not really being needed by the grid, and then you kind of use it in the day if you need to. That's sort of the other option. The article does link out to another LREG article, which I won't go into massively, saying that this isn't just Ireland that's having these sorts of concerns. UK government's had conversations, National Grid has had conversations, and that data centers generally do have backup power solutions, typically by diesel powered generators, but diesel's expensive, diesel's dirty, and the auto switchovers onto these generators are not great either. So yeah, this is, as you say, this is very at odds with the green agenda, if you like, but it's, I think, something of a necessary evil if we want to keep using our hyper-connected services.
Yeah, I mean, I guess there's a strong possibility that these diesel generators will never be fired up, but it's going to be interesting to see what happens over this winter with fuel shortages and that kind of thing. It could be the best disaster recovery test that the entire global internet infrastructure has ever seen. If we're all running out of power, and there is talk of these enforced 3-hour power outages in the UK over the winter. So it's going to be interesting to see how all these facilities actually handle this. As you say, whether the switching gear can gracefully switch over to the diesel backup generators, which is something that they are supposed to test on a regular basis. Whether they actually do or not, I guess we'll find out. But of course, the other thing then is if they are running on diesel, can they actually get any diesel or enough diesel to keep the things running? If they have to run on diesel for any extended period of time, of course, the diesel will start to run out. It will need to be replenished. And the article does talk about, the fact that the stocks of diesel have been quite volatile recently, which is why we see the pump prices going up and down like a yo-yo. So it's going to be interesting to see with that additional demand on the diesel how well the industry is going to cope with that. So interesting times with all this power generation and so on and so forth. I guess though, if whether or not the data centers need to stay up if we're all suffering power outages, which are likely to affect our homes and the mobile networks and so on and so forth. If all the websites are up but nobody can access them, does it really matter? So we're going to have to wait and see. My wife was trying to send me out to buy firewood yesterday because she's hugely concerned about the energy crisis, and I think she read an article that the UK only had something like 9 days worth of gas left in storage over the weekend. So certainly interesting times that we're heading into over this winter. So I think that brings us to the end of our time really today, John. So thank you very much for those insights. We will be back next time, but this brings us to the end of episode 4 of LogiCast. So don't forget to subscribe to the podcast. It's available via all major podcast distribution channels. We'll leave it there and we will see you next time. Thanks for listening.